Welcome everyone. In this video I'm going to show you a Peltier cooler related experiment. This video is dedicated to a question which I receive quite a lot and I want to show you in reality. So before telling you the question, I want to show you my system because then it becomes more easy to actually tell you what the question was. And since this was really popular question, I really wanted to make this video. So first of all, let's go through my cooling system and see what is visible on the table in this big mess. So let's start from the middle, which is this metallic object here, and that is nothing else than actually this kind of configuration. So there is a 4x4 centimeter aluminum cooling block at the bottom, and then there is a TEC12715 Peltier cooler here. The hot side is facing towards the bottom part. And then on the top, on the cold side of the Peltier cooler, we have another water cooling block. So basically this is the configuration there. And then this cold side of the Peltier cooler is supposed to cool the liquid circulated in this cooling block. And then let's start with the cold part. So the water is cooled down inside this cooling block, and then it goes through a tube, and then it goes inside this 8x8 centimeter radiator, and then it passes through it, and then through another tube it goes back to this pump, and then the pump pushes the water back to the aluminum cooling block. And actually the question is related to this part of the Peltier cooling system. So people were asking if this is viable and if they can get cold air out of this system. So what they wanted to do is that they wanted to cool down the water in that cooling block and circulate it in this system, push it through a radiator, and you push air through this radiator. There is a fan at the back side, so the cold air is supposed to come towards the camera. And if this can be used as an AC. So I usually say no, and I want to back up my statement. It can be used as an AC, but not with this kind of configuration. You will need much more Peltier coolers, much better power supply, much better cooling, which makes the whole thing, let's say, unfeasible, if there is a word like this. So it's not a really viable thing to do because it's just very inefficient. And why? So first of all, Peltier coolers should not be used like this. You are not supposed to cool liquids with them and then transfer the liquid to a large distance, relatively large distance, and then capture the heat with this radiator. Because technically what you do is you have a cold liquid circulating in the cold side, and then you have the room temperature air which is pushed through the radiator. So the room temperature air inside the radiator will warm up that cool liquid, so we introduce heat into that system, and then that heated up liquid goes back to the cold side. Then that heat is sort of removed by the Peltier cooler and then ends up on the hot side and then goes into that radiator, and then it's dissipated into the air again. But this thing is very inefficient because Peltier coolers are already very inefficient, like 10 to 15% efficiency, while compressor-based things are around 30-40%. So it's not only that, but you introduce a lot of thermal resistance here. So first of all, you have to transfer the heat from the cold side to this heating block, and then the heating block is transferring the heat to the water inside it, and then you are transferring that cold water through pipes inside this radiator. So then you have another, let's say, obstacle, because then you have to get the heat through the radiator inside the water. So it's quite complicated, and preferably you want to put the object that you want to cool directly on the cold side of the Peltier cooler. So for example, when you are cooling, let's say, a diode, a laser diode, or a silicon wafer, which is usually used to capture X-ray, then you usually put the semiconductor directly on the chip, or you are using a cold finger, which is just a big piece of aluminum or copper, preferably copper, and then on the top of that copper piece, so let's say this is that thing, you put your semiconductor and then you cool it down. But here you add a lot of unnecessary stuff, so that further decreases that already bad thermal properties of this. And by thermal properties I just mean that the efficiency of cooling and so on. But still, I just want to show you this experiment. So what happens on this cold side I already explained, but just let's repeat it. Water gets cooled down in this cooling block, and then it enters the radiator. We run air through the radiator, so we will sort of extract the cold, but in reality we cool down the air with the water which passes through the radiator, through the fins or lamella, and then the slightly warmer water returns to the pump, and then it gets back to the cooling block here to get cooled down again. And on the hot side we have the opposite of this. So on the hot side we are expecting a lot of heat. First of all, since I'm using the 12715 and I will use this Peltier cooler nearby its maximum power, then we are expecting something like 250 watts of joule heat. That's just one part. And if everything goes well with this configuration, we can squeeze out roughly 80 to 90 watts of cooling power. So that will also end up on the hot side. So at the end, we are transferring heat to this cooling tower, which is about 340 watts. So we try to dissipate 340 watts with this thing. And this is a 24 by 12 centimeter radiator with 4 fans installed on it. So on this side, they are pulling out the air, and there are 2 similar fans on the back side. They are pushing the air into the radiator. So I realized both push and pull configurations, so people cannot complain that I installed the fans in the wrong way, like some people did. So that is all. And then I have my thermometer. So one temperature will be read inside this water tank. So that's just purely the water coming out from the radiator. So that's like the water temperature which will enter the hot side cooling part of the Peltier cooler. And then we have another thermometer here. This will be showing us the air temperature, so the room temperature. Another thermometer is placed in this pump, and then this will measure the temperature of the water. So we will try to aim just slightly above 0 degrees Celsius to not freeze the water inside this unit and obstruct the way of the water. And then another thermometer is here. This is the 4th one in front of this radiator. So then the cold air is supposed to come out in this direction towards the camera, and this will measure the air temperature. But just to be on the safe side, I squeezed in a K-type thermocouple in between the fins of this radiator, so that will be measured by this thing. And then I have a power supply here, and this is a very powerful power supply. So 30 volts and 20 amperes can be provided. The cable is here, already attached to the Peltier cooler inside this kind of sandwich there. So we can run the Peltier cooler at the maximum power, but you will see the display here. And technically that's all. I have also a fan on the back side of this radiator. Here are the 2 cables. So I will also attach them to the power once the temperature in this circuit reached the 1 or 2 degrees Celsius, because then I say that at that power we can check how the actual airflow affects the temperature in the circuit, and then we can either change the power or do something else in case something happens. So now what I have to do, I have to fill up these things with water. I will try to measure the amount of water that I put in the systems. So that can be used as some kind of information for you, hopefully. And then I start up the pumps and the radiator fans on that side. And once everything is looking normal, I start to increase the power on the Peltier cooler until I reach nearly 0 degrees Celsius in this tank, which is the cold side cooling loop. And once that is reached, I turn on the fan on the back side. So then I introduce the fresh air to this, and we will see if this works as an AC or not. And I suppose it will not cool down the air significantly. So we will see. So let me just put everything together and then I will return. So the system is assembled now and everything is filled up with water. As you can hear, the pumps are running. Actually, it's that pump which makes the noise. This is very, very silent, but it runs the water. So let's just read the temperatures and let's see what is happening. So I was using just some tap water, so it might be colder than the room temperature inside the water cooling loop, but it doesn't matter. So this thermometer shows 25.7 degrees, and then this thermometer shows 21.7 degrees. This thermometer shows 26.2 degrees, and this thermometer, which is the room temperature thermometer, this guy here, is showing 26.2 degrees. So this and this is roughly the same. And then this thermometer, 22.7, that is the thermometer inside the radiator, basically. So as you can see, roughly 23 degrees. And now I'm just powering this thermometer with this power bank, so it's nothing fancy. The power supply is at 0 voltage and everything. And I just got another cable and connector for this fan, but as you can see, the fan is not turned on right now. We will do that later once the temperature in this loop is nearly 0 degrees Celsius. So now I will try to adjust the voltage and start to run the system and see what happens. So since this is a 15 ampere unit, I don't want to rush all the current through it immediately. So now I am running 5.14 amps and this is at 5.52 volts. So this is roughly just 25 watts of power used to run the Peltier cooler. So this should not have any significant effect yet, but still I just want to run it for a while to start to cool down the water inside this loop. So I run this for like 10 minutes and then I come back and check what happened with the water, and then I run this thing at, let's say, 10 amps and wait another 10 minutes. So let's check back in 10 minutes. So let's check the temperatures. So the temperature in that cooling loop, which cools the hot side of the Peltier cooler, is 29.5 degrees. And then the temperature here in the cold side loop is 15.5 degrees Celsius. And then the temperature here, which is just the room temperature, is 26 degrees. And here it's 26.5 degrees. So that's the room temperature. And also this thing shows 16.4 degrees Celsius. So this is very close to the temperature read here in the water. So let's bump the current to 10 amps and see how the temperature develops in the next 10 minutes. So I set the current to 10.15 amps and the voltage is 11.7 volts. So this is roughly 110 watts of rejected heat. Plus we have the heat transferred by the water, and that ends up in that cooling system. So let's wait another 5 minutes and let's see how the water behaves in the cold side loop. So we reached another 5-minute mark. So let's check the temperatures. So the temperature there in that tank is 35 degrees Celsius. So now the hot side is really heating up the water in that loop. And then the water temperature in this loop is 10.8 degrees, and in between the lamella of the cooler or radiator there, we read 11.8 degrees, so they are relatively similar. And then here it's 25.7 degrees, so this is slightly cooling down the temperature around it, so that's why this is a bit colder. And then here we have 27.2 degrees Celsius, because now the air is getting a bit more warm in this area, so the room temperature is going up. But we have a lot of space, so the overall room temperature is still unchanged. So this is what we have now, and we are at like 75% performance of this thing. So what my proposal is that I go up to 13 amps and wait, let's say 10 minutes, and see how the temperature here changes. So 13.06 amps and 16.3 volts. So now a lot of power is running through the Peltier cooler. The wires are a little bit warm, and then we can expect something to change here. So let's wait 10 more minutes and let's see what happens. So I've been waiting for more than 10 minutes, so let's check what happened. And in the hot side part, we are at 39.2 degrees Celsius. In this tank, which is the cold side loop, we are at 10.8 degrees, so there is no significant change in the temperature. The temperature here is 26 degrees, and the temperature here is 28.5 degrees, so the room temperature increased still a little bit. And then in between the lamella, or in between the fins, 12.3 degrees can be read here. So now the question is, what happens to the water temperature if I turn the fan on? Because that would pose the real challenge to the Peltier cooler, because then we start to introduce more heat to the cold side. So now I turn on this fan, and now this is running, but then this is pushing some colder air. But let's see this after like 5 minutes, and let's see how this behaves and how the temperature changes in this environment. So I waited 10 more minutes, and I've been running the fan on the cold side. So first of all, the temperature there in the hot part is 40 degrees, so it got a little bit warmer. And then the temperature inside the tank now is 22.2 degrees, so it almost came up back to room temperature, because we started to push the air through the radiator on the cold side. And then here the temperature in front of the radiator is 23.7 degrees Celsius, and at the same time in between the fins is 24.4 degrees. So this is again almost roughly room temperature. And then the temperature read here around this hot area is 28.7 degrees Celsius. So you can see that we are not that much far away from the room temperature when we turn on the fan. And that would be the point of this whole thing, that you want to extract the cold from this cold side loop by pushing the air through the radiator and expecting very cold air coming out. But as you can see, this doesn't really work, because the temperature that we read now when the fan is running is room temperature, and that's not what people would expect. So this is the problem of this thing, that the Peltier cooler just cannot really keep up with this kind of capacity that we would need to really push cold air. Because when you are using the AC, the air which is actually coming out from the AC is much more colder than the room temperature. But of course that air is getting mixed with the room temperature air, and then you get some kind of average after a while. But you need much more cooling power. And in order to extract more heat from this system, you will need much more Peltier coolers. So I'm not saying it is impossible, but it's not feasible, because now I'm already using 12 amps and 15 volts just to power one single Peltier cooler, and that creates this cooling effect. So then if we put some kind of linear correlation in between the power we use and the temperature decrease that we reach, we will see that we will need an enormous amount of power to cool this kind of cooling system and provide some sufficient cooling. So as you can see, this doesn't really work as expected, or as some people think. But this was the point actually in this experiment, that I wanted to show you that this thing really doesn't work as some people might expect it to work, because just because of the principles how this thing works. So I hope that this video was somewhat useful to you, and I hope that I could show you this in the expected way, that you wanted to build something similar, but then you can see that it doesn't really worth it, especially if you are using just one single Peltier cooler. And also you can see it in many fake videos that they build very similar system, but with like the 6 ampere unit, not even the 15 ampere unit, and they claim that they built AC, but that's just not the case. So yeah, if you put your hand here, you can feel like a very, very gentle breeze, but that doesn't have really effect. Let's say my hand is here, which is like half a meter away, and I cannot even feel the cold air anymore. So then, if you are in a hot climate or whatever, this will just not work. And also you have to put the heat somewhere. So even if you put that thing outside, it will not help at all. So this is what it is. So I hope that this kind of demonstration was helpful or useful to you, and I hope you will not waste your money trying to build this kind of thing, because this actually costs a lot. What you see here with the power supply, with the cooling system, and all these things scattered around the table. So I hope you can find some better things to spend your money instead of building this useless system. So I hope this video was helpful, and see you in the next video.